This is worksheet 821, substitution method, and we're going to apply the substitution method to solve these systems of linear equations. From our discussion of substitution, we recognize here in our first equation that we have an equal sign, and that equal sign communicates that the letter y and the expression 6x minus 23 on the right side of the equal sign are of equal value and therefore are interchangeable. So in a second equation in the system, wherever I see the letter y, I can substitute or exchange this 6x minus 23 for that y. Now it happens in this system that I also have a second equation where y is also equal to this negative 4x plus 17. So again, what that communicates is that this negative 4x plus 17 can be interchanged with a y in the other equation. So actually I could either substitute the 6x minus 23 in for this y, or I could substitute the negative 4x plus 17 in for this y. As long as I do it in a second equation, I'm okay, and it doesn't matter which way you do that. Again, the purpose of doing that, or what that's going to do, it's going to create an equation that has just the letter x in it, which then allows me to determine the value of x. So I'm going to go ahead and take this first expression of 6x minus 23 and substitute it in for this y in the second equation. So that's going to give me 6x minus 23 that I substituted in for this y, and then equals this rest of this, negative 4x plus 17. And again, you'll notice by substituting in this expression that has an x in it, in the place of the y, I now have an equation that has just the letter x in it, which will allow me to solve or determine the value of x. So I'm going to add 4x to both sides so that x is no longer over here. So these added together is going to give me 10x. Minus 23 still over here. I then have my equal sign. Negative 4x and 4x is 0, so I don't have to write that, or plus because I'm going to have another number over here, 17. I then want to go ahead and get the 23 on the other side so I can have the x by itself. So that's going to give me 10x. 23 and negative 23 is 0. Bring down my equal sign, and this is going to be 40. And then dividing by 10, which again we've talked about as multiplying by a tenth, that's going to give me a 4. So that gives me the x value of my answer, and again I now have to figure out the y value. Now again, as a reminder, what does this mean? What this equal sign means is that the letter x is now interchangeable with the number 4. So in any of these equations up here, I can substitute in the value of 4 for any letter x that I see, because the equal sign tells me that they are of equal value. It does not matter which one you do here, just pick an equation and do that. So we'll go ahead back up to this first equation, and wherever I see the letter x, I'm going to interchange that or substitute in the number 4. So that's going to give me, in the first equation, y equals 6, and then there's that x, so I'm going to substitute in the number 4 now. Minus 23. So then I can simplify this, 24 minus 23, which then gives me a y is equal to 1. So you'll notice I have my order pair 4, 1. And we're just going to repeat that process for the rest of these problems on this worksheet. Seeing how I have the odd ones listed here, we're going to go ahead through this worksheet and we're going to do all of the odd ones for you. Because I can just kind of easily scroll down and do this. So we're going to scroll up here to number 3. We're going to go ahead and do number 3 on this worksheet. Again, in my system I have the letter y is solved for on both equations, so the equal sign communicates that I can substitute the expression in on the right in for the letter y. So I'm going to go ahead and continue and just put this first one in here. So substituting this expression 3x minus 21 in for the letter y here, I then have my equal sign, and then I have the expression on the right. Again, that gives me an equation that has just the letter x in it, so I can solve for that. So I'm going to add 2x here to both sides. So that's going to give me 5x. I still have negative 21. I have my equal sign. 2x and negative 2x is 0 plus 14 because I have another number here. I don't need to write the number 0. I then want to isolate the x, so I'm going to add 21 to both sides. So that's going to give me 5x is equal to 35. I won't use that color green again, that's kind of hard to see. And then we're going to multiply by a fifth, which is dividing by 5. Okay, so the 5 is reduced, leaving me x, and then that reduces with this, giving me a 7. So that gives me the first part of my ordered pair. Again, what this means now here is that the number 7 is interchangeable with the letter x in these equations. So I'm going to go back to my first equation, and I'm going to write it. And when I come across the letter x, I'm going to substitute in something of equal value, which in this case now is a 7. Okay, so then I'm going to simplify this expression. So y is equal to 21 minus 21. So y is equal to 0. So I have 0 as my next answer, or as my y value. And so this ordered pair 7, 0 is my solution to the system. Number 5. Again, we have two equations, both of which are already solved for the letter y. And just to show you that we can change things up a little bit, this equal sign means the letter y and this negative 6x minus 5 are interchangeable. So I'm going to substitute the second one into the first letter y. So I'm going to have negative 6x minus 5 is the same as the letter y, or is interchangeable with the letter y. So I did that. And then I'm going to have 8x plus 9. So again, we're going to solve so that we get the x on the same side. So we're going to add 6x over here. And the reason I'm adding 6x is because I want this to remain positive over here, but it wouldn't matter. 6x and negative 6x is 0, leaving me negative 5. Then I have my equal sign, 14x, and then 9. And then I want to get the x again by itself, so I'm going to subtract the 9 from both sides, adding the opposite. So that's going to give me negative 14, 14x. And then I'm going to divide by 14. Again, I'm going to do it this way this time, just for some of you like to see me do it this way rather than multiplying by that reciprocal, but it's the same thing. So this is going to reduce to 1, leaving me x, and then now I have a negative divided by a positive, which is a negative 1. So I have my x value. Now again, that tells me that x and negative 1 are interchangeable, so when I go back to these two original equations, I can choose either one and substitute in a negative 1 for the letter x. So I'm going to go back to the second equation this time. So it's going to give me y equals negative 6, and now I'm going to substitute in a negative 1 for x because they are of equal value. And then I'm going to solve this expression here. A negative times a negative is a positive. So y is equal to a positive 1. So I have the positive 1. So my ordered pair is negative 1, 1. Looking at number 7, again we have y is solved for or by itself on both equations, so I can substitute either value or either expression in for the letter y. Again, I'm going to choose the second equation, and this x minus 1 is of equal value to a y, so I'm going to substitute in this whole expression for that y value. So that's going to give me x minus 1, substituting that expression in for the letter y, equals negative 5x minus 1. Now I'm going to solve this equation that now has just the letter x in it for the letter or for the value of x. So I'm going to add 5x this way this time. Again, I like to keep that variable positive. So when I add these together, that's going to give me positive. I still have negative 1. 5x and negative 5x is 0, but because I'm subtracting negative 1 from that, I don't need to write that because I am going to have a negative 1 over here. Okay? And then we're going to add the opposite here. So we're going to add 1 to both sides. Okay, 6x. I have negative 1 plus 1, and now here I have negative 1 plus 1, which is a 0. Now, because there's nothing else over here, I need to write the 0. A lot of times students will figure that 0 and not remember what I need to write here. The reason we didn't write zeros on those earlier problems is because we had other numbers over here, so we didn't have to do that to kind of have something on this side. But this side time we want to do that. So we're going to divide by 6, which is multiplying by 1/6, multiplying by the reciprocals. Those 6's reduce. And now 0 times anything is just 0. So I have x value of 0. Now that I know what x is, I can go ahead and substitute in that value into either of these other expressions for the letter x. So I'm going to choose this second equation. So I have y equals, and there's a letter x. I'm going to substitute in the 0 because that's of equal value. Gives me minus 1. So y is equal to negative 1. So again, substitution allows us to determine the value of a variable by removing one of the two variables from the expression. On number 9 here we have again two equations, but we'll notice is a little bit different than the other ones previously because only one of the equations is solved for y. But that, again, that's all we need. We have y and we have an equal sign. So what that tells me is that the letter y and this entire expression over here are of equal value. So just like we did before, wherever I see a y in my second equation, I can substitute or exchange that out for something of equal value, which I have right here. So don't be freaked out just because it doesn't look the same. We're still going to apply the same process. So I'm going to write this second equation here, and wherever I see the letter y, I'm going to exchange it for this entire expression right here. So that's going to give me negative 5x minus 2. Now there's that letter y, and so because I'm putting in multiple terms here, 3x plus 7, that whole thing there is taking the place of the letter y. So all I've done is exchange something of equal value for the letter y. I've put in this entire expression here. And then I continue writing my equation negative 9. Now I simply have an equation where I have to distribute first in order to get rid of the parentheses or to remove the parentheses, but we're going to solve this just like we've been solving equations all year long. Okay, so the negative 2 times the negative 3 is a positive 6x. The negative 2 times the 7 is negative 14, and it equals negative 9. That removes my parentheses. Now, in solving equations, before we go on, we want to simplify each side or add like terms. So I have a negative 5x and 6x here, which can be added together to give me x. Okay, now that both sides have been simplified and they've been added like terms, we can go ahead and get the letter x by itself by adding the opposite of 14 here. So 14 minus 14 is 0, and negative 9 of 14 is 5. So I have my number for x. Now again, I can go back to either of these equations, and wherever I see the number, the letter x, I can substitute in something of equal value, which I now know is 5. Because I want to determine the value of y, and that's my goal, and right here, y is already by itself, I'm going to go ahead and use this equation and substitute in the x value here. But I could use the other equation if I wanted to. So y is equal to negative 3. I now know the x value is a 5 plus 7. So now we have negative 15 plus 7. So y is equal to a negative 8. So I have my ordered pair 5 and negative 8. Number 11 here, we'll notice that the first equation is not solved for a letter, but the second one is. So again, we know that the equal sign tells us that this letter y and this entire expression over here are of equal value. So in any other equation in the system, which happens to be this one, I can put in this negative 5x plus 6 wherever I see the letter y because they are of equal value. So rewriting this first equation then, I have negative 3x minus 4. There's that letter y. So I'm going to substitute in something of equal value. Negative 5x plus 6 has equal value, and then I'll finish rewriting the expression. And again, you'll notice that in doing this, the letter y is no longer in this equation. Only the letter x is, which allows me then to determine the value of that letter x. So using our steps for solving equations, we're going to remove the parentheses first by distributing. So that's going to be 20x, and then at negative 24 equals negative 7. We're then going to simplify each side of the equation by adding like terms. So I have like terms here that I can add together. There are no more like terms. So now I'm going to isolate the letter x by adding the opposite of everything else. So we'll move this to the other side here like this. So it's going to give me 17x is equal to a positive 17. I then am going to divide by 17, which means I multiply by the reciprocal of 17. So those 17's reduce, leaving me the number x, and those 17 reduce, leaving me the value of 1. So I know that the x value now is a 1. I now need to determine the y value of my solution, or of my system. And again, I'm going to go back to the second equation because it's already solved for the letter y. So when I substitute in a number for x, I'm just going to have to simplify this one side. So we're going to take this second equation here, and wherever I see an x, I'm going to substitute in something of equal value, which I now know is a 1. And then simplify the expression. So this is going to be negative 5 plus 6, so y here is a 1. So I have my ordered pair, which is the solution to my system. Number 13, again, my first equation is not solved for a letter y, but my second equation is. So again, equal sign tells me the letter y and this expression over here are of equal value. So in my equation, in my system, I can substitute this expression in for the letter y. So taking this first equation and rewriting it, and when I come across a letter y, I'm going to substitute in something of equal value, which is 3x plus 8 equals negative 19. Now I'm going to use my steps for solving an equation to determine the value of x. So first step is to remove parentheses by distributing. So that's going to be minus 24, negative 19. The next step is to simplify each side of the equation by adding any like terms that I have. So I have like terms here. So negative 5x minus 24. Both sides have been simplified, so now I'm going to isolate the letter x by adding the opposite of those things that don't contain an x. So that gives me negative 5x. The 24 and negative 24 equals 0. And then this is going to be a 5. And then I'm going to multiply by the reciprocal, or to divide by negative 5. So the negative 5 is reduced, leaving me x. This is a positive and a negative, so that gives me a negative 1. So the x value of my solution is a negative 1. And now to determine the y value, I'm going to go back to this expression that's already solved for y. And wherever I see the letter x, I'm going to substitute in something of equal value, which I now know is a negative 1. So y is equal to 3 times the x value of negative 1 plus 8. So y is negative 3 plus 8, so y is going to be equal to 5. And so I have my solution to my system. So one final problem here on this worksheet for substitution. Again, the second equation has been solved for the letter y for me. So again, y and this expression 2x minus 3 are of equal value and therefore interchangeable. So going back to my first equation in the system, I'm going to rewrite this equation, but wherever I come across the letter y, I'm going to substitute something in of equal value, or substitute, and then finish the rest. And now I have an equation that has just the letter x in it, which I can now determine its value by simply following my steps of solving an equation. So we're going to remove parentheses first by distributing. Plus 6 minus 3. We're then going to simplify each side of the equation by adding like terms. We are then going to isolate the letter that we're solving for by adding the opposite of anything else that's on this side. So we're going to subtract 6. Negative 9x equals negative 9. We are then going to divide by multiplying by the reciprocal, because that's what division is. So the negative 9's reduce, which give me x. The negative 9's reduce, giving me a positive 1. So I now know what the x value of my system is. I'm going to go back to this equation now because it's already solved for y. And wherever I see the letter x, I'm going to substitute in something of equal value. So I now know that 1 is of equal value to an x. So I substitute the number 1 in. And so y is equal to 2 minus 3. So y here would be equal to -1. So I now have the solution to my system. Okay, so substitution is simply substituting in something of equal value, and in doing so it allows me to determine the value of one variable by kind of getting rid of or eliminating that second variable from the expression.